Today we'll be looking at sets of relations and determining whether the set of relations is a function or not a function. We'll look at relations that are displayed as an ordered pair, displayed as a table, displayed as a mapping diagram, and displayed as a graph. So let's first define what makes a function and not a function. A relation is a function when there are no repeat domains and it passes the vertical line test. A relation is not a function when there are repeat domains and it fails the vertical line test. So let's think for a moment. Is a relation always a function? Is a relation always a function? And is a function always a relation? A relation is not always a function. We look at the relation and we're going to determine whether it is a function or not. But a function is always a relation. And if I wanted to represent that with a Venn diagram, it would look like this. All functions are relations, but all relations are not functions. So let's determine whether a set of ordered pairs is a function or not. All right, the set of ordered pair on the left side is a function. The set of ordered pairs on the right side is not a function. So take a look at those two sets of ordered pairs and think to yourself, why is one a function and the other is not? The set of ordered pairs on the left side is a function because no repeat domains. That means the x values don't repeat. 4, 7, and 5. So that makes it a function. But on the right side, this is not a function. This relation is not a function because the 8's repeat. We have a repeated domain. Let's look at a set of relations displayed as a table. Again, on the left side, this table is an example of a function. On the right side, this is a table that's an example of a set of relations that is not a function. Again, think to yourself, why is one a function and the other is not? Again, on the left side, we have no repeat domains. The x's do not repeat. 3, 4, 5, 6, 7. So it is a function. But the y's repeat, and that's okay, because it's okay for ranges to repeat, and it's still a function. On the right side, this is an example of a set of ordered pairs, a table that's not a function. And that's because we have 2 4s for the x value. The domain repeats. Let's look at an example of a mapping diagram. On the left side, this represents a function. On the right side, this represents a mapping diagram that is not a function. Again, think to yourself, why is one a function and the other is not? The left side is a function because, again, we have no repeats in the domains. 1, 2, 3, 4. And on the right, we have the points 210 and 220. So the domain of 2 repeats, so it's not a function. And our last example is looking at a graph. The graph on the left side is a function. The graph on the right side is not a function. Again, think to yourself, why is one a function and the other is not? Well, when we look at graphs, we think about the vertical line test. And the left side is a function because it passes VLT, or the vertical line test, and the right side fails the vertical line test. And remember, that means if I take a vertical line and pass it anywhere through the graph, it only touches the graph once, at one point. So that is a function. So we say passes the vertical line test. On the right side, you can see as I pass the vertical line through the graph, it's touching the graph at more than one spot at a time. So we say that fails the vertical line test.